So let's go over formal charge. So students have been really confused with formal charge and they're like, I don't understand formal charge. I don't know how to calculate it. I don't even know what it is. And so let's go over formal charge together. So formal charge is something that chemists use and is to determine what is the most likely structure, Lewis structure, when you have more than one possibility. What does that mean? So you can have resonance, right? So again, if you don't know what resonance is, you can go check out my video on that. But pretty much resonance is describing the delocalized electrons, how they move. Again, that's more organic chemistry, but for the purposes of our video, just need to know that there can be more than one structure. And again, that's resonance. And again, formal charge is to determine what is probably the most likely structure, because again, it's going to, usually what happens is you're going to put the negative on the most electronegative element, you're going to put the positive on the most electropositive, but if you can have them all neutral and happy, probably that's the best one. But again, if you want to go check out resonance, you can go check out my videos on that, and let's go into formal charge then. So again, formal charge is a method to figure out what is the most likely, most plausible Lewis structure when you have more than one Lewis structure, obviously. So why do students get confused? Well, students get confused because of the way that textbooks have the rule that you're like formal charge equals valence electrons minus associated electrons, and then some textbooks they'll use like unshared and shared, and so students get really confused. And so what I like to do is I like to use this formula. Formal charge equals valence electrons minus bonds plus dots. Really simple. So bonds, the number of lines you have, okay? Dots, the number of dots that you have, the number of electrons that you have. So let's get into all of these examples. So the first one is going to be methane, which is CH4. So let's look at the carbon. So carbon has 4 valence electrons. And if you don't know how to know which one has what valence electron, you can go check out my last video on valence electrons. It's probably inside of the, let me check really quickly. It's one of the most recent videos that I did. Lewis dot structures. It should be in there. So go check that out. Now, carbon has 4 valence electrons. How many bonds does it have? Well, you can see that it has 4 lines attached to that carbon. So it's going to be 4. How many dots do you have? I don't see any dots. So that's going to be 0. 4 minus 4 plus 0. So 4 plus 0 is 4. 4 minus 4 is equal to 0. So the charge for carbon is 0. Now, let's go to the hydrogen, okay? So hydrogen has 1 valence electrons. How many lines attached to it? 1. Do you see any dots? No. So that's going to be 0. So we know 1 minus 1 is equal to 0. Okay, so some of you are going to be like, wait, what about the other hydrogens? Again, they only have 1 line. So again, you can calculate for each, but it's kind of redundant because you know hydrogen is 1 and all the hydrogens only have 1 line attached to it. So it's going to be the same. So all these have a charge of 0 as well, okay? Now, let's dive into water. So what about water? So oxygen has valence electrons of 6. How many bonds does it have? I see 2 lines. How many dots does it have? I see 4 dots. So 6 minus 6 is equal to 0. Hydrogen, again, is going to be 1 minus 1 equals 0. Okay? Now let's go to CO2. So again, carbon is going to be 4. How many lines do you see? You see 2 sets of double bonds. Again, you see 4 lines. So 4 minus 4. Again, you don't have any dots, so I'm just going to do 4 minus 4 is equal to 0. Let's go to oxygen. Again, the oxygen on the left and the oxygen on the right are the same. So they're going to have the same charge. Oxygen is 6 valence electrons minus 4 dots plus 2 lines. 6 minus 6 is equal to 0. Okay, let's go to nitrogen now. So nitrogen is 5 valence electrons minus how many lines? I see 3 lines, a triple bond. How many dots do I have? I see 2. So 5 minus 5 is equal to 0. Okay, again, the nitrogen on the right is the same as the nitrogen on the left. So they're going to have the same formal charge. Now, what about beryllium? So BeF2. So Be, again, is going to be 2 minus 2. There's no dots, so again, it's going to be 0. Fluorine is going to be what? Well, fluorine we know is 7 minus 1 line, so 1. How many dots? 6. 7 minus 7 is equal to 0. Now, for some of you, I know they're going to be tempted to go on your exam and put everything as 0. No, I just want you to be comfortable with calculating formal charge, but again, that does not mean that it's always going to be 0. In the next example, I have the perfect way to show you that it can change in the formal charge. So these 3 oxygens are not the same. They're not. So let's go one by one. So I'm going to go from left to right. Oxygen 1, oxygen 2, oxygen 3, or the one on the left, the middle, and the one on the right. Okay. So for oxygen 1, we know that oxygen has 6 valence electrons minus, again, you have 2 bonds, you have 4 dots. So the first oxygen is going to be 0. It's going to be neutral. Sorry for my 0, but it's 0. Now, what about the oxygen in the middle? Well, again, it's going to be 6. How many lines do I have this time? I have 3. How many dots do I have this time? I have 2. Oh, wow. So I have positive 1. So the one in the middle is positive 1. Okay? 6 minus 5 is 1, so it's going to be positive 1. Now, let's do the last oxygen, the one on the end. So again, you have 6 minus how many bonds? 1. How many dots? 6. 6 minus 7 is equal to negative 1. So oxygen 1 is 0. Oxygen 2, or the oxygen in the middle, is positive 1. And oxygen 3, the last one, is negative 1. So just to show you that just because it's the same element does not mean it's going to have the same formal charge. It depends on how many bonds and how many dots you have, as well as obviously the element of how many valence electrons it has. So again, formal charge is equal to valence electrons minus bonds plus dots. If you enjoyed the video, again, it takes time to create this content, so please follow, like, share, and thanks again for watching. If you need another video like this with more charge examples, let me know in the comments, and thanks again.